So this video is how to draw the epicycloidal curve for the given parameters. So I used my old file that I was using for drawing the cycloidal gears for my models. There was a small error, but now it is fixed. So first of all, I have this defined parametric. So in the model, I have in the parameters, I have parameters R1, R2, E, that is the ratio for the gear, and eccentricity. This is the eccentric, but in this case we will use it as a equal to the second radius. So I also have this formula for R1 calculation that gives me the calculation for the diameter of the gear, basing on the ratio of the gearbox that I want. So for this particular case, that R1 should be 60 and R2 should be 5, I have put 5 and appropriate ratio to have the R2 calculated as 60. Also eccentric, I need eccentricity, I need equal to the radius, so my point, that because the curve is drawn for the point, not for the point on the curve, but for the point on the eccentric. Well, in this case we will use eccentric equals the second radius. So I have these parameters defined, they have calculated, and here I have the piece of this hypocycloidal, this is the epicycloidal curve. My equations are opposite what are given in the forum, because I start from the bottom, not from the top. So I switch the functions. So basically, this is the setup. First wheel of the radius 60, second wheel of the radius 5. These are linked to the parameters, and basically this curve has an equation. Sorry, I probably need to go there and edit equation curve. So this curve has an equation according to what we have here. Sorry, just okay, I don't want that, I want that. So okay, and now probably here. So these equations are equivalent to those, only instead of the small radius I have the eccentric that in this case is equals the radius. So this point is here. And now this works as long as you do not exceed the touch point here in the range for the argument for those functions, because once you exceed this point this way, although Inventor shows that this curve will go directly, will go this way, but let's say if I put, so I have this I have defined as 360, this is in degrees around, divided by 2 multiplied by I plus 1. So this gives us only from here to here, and it works no matter what parameters I put, because it is also parametrically linked. So although Inventor indicates that this curve is here, once I put plus, let's say 0, 0, 1, 0, 2, I am getting that this curve intersects irregular at parameter 15, because for the parameter 15, which is exactly the point there, Inventor has a self-intersection of the curve, because this curve, in terms of how Inventor evaluates the curve, is self-intersecting here, because because the tangent of the curve is not continuous here. The tangent of the curve here is how to the function here is sharp. I could go with minus this, Control C, Control V, and I put minus instead, and then I have function from here to here, and it still works, but for my reasons, yeah, I can leave it like that. But because of that, the function is moved, so I don't want that. I need to have it from here to there. So this gives me the half of the lobe. Then I can mirror it and pattern it around. So in terms of how to build the model, you need to connect this with that. So exactly this with that. Probably it will not work, but we can try that. So here to here it's 360 divided by 2 multiplied by I plus 1. Divided I plus 1 divided by 2 razy cannot evaluate. Why you cannot evaluate these parameters? I no, not D1 but I Okay, let's probably I had and from here to here, and now you can try to extrude that and then mirror it and then pattern it. Pattern solids, rotation axis, z-axis, I plus 1. Because I didn't have this. Create pattern failed, so attempt to did not try with different inputs. Solids, let's try that. And now, or we can just do it another way. So obviously there are some problems, but yeah, so as you can see there are some problems with that, but this is doable. What I was doing before, I was doing something like that. I was creating another part. I was then deriving that part, and then it is treated as the derived solid, and it is not parametrical anymore, but it is linked, so you can then copy it and pattern it. We can try this. So let's create another part. Now derive. I believe this was that. If I which is curve IPT, select that. Solids, okay, and now we can try to do that. Not again. I'm not sure why it is not working now, but generally once you have that, you can generally get around with that. So either to slice it, we should see what exactly is the problem here, but as for the curve, we have it here. We could try perhaps, but this will not work probably. I will then delete that and delete that. No, not this one. Select other. So generally, as for the curve, it works like that. You need to have the proper range for the argument of the function. I will save that and upload that.